All right, so we're recording. Okay. So we are on week 15. So you should be pretty happy about that, I'm sure, right? Summer is coming. So this is the last lecture today. It's just a series of miscellaneous topics to wrap up things. We've had the full semester. We worked on Linux commands, scripting, etc. On Wednesday, you can remember it's a kind of an open lab. You can work on the project. That's essentially the idea, and then I'll sit with you guys just to see where you are um, on the project A and B. Ask any questions, and then presentations will be a week from today, Monday, right? And that's it. That's the semester. Usually I have Monday and Wednesday for presentations, given that sometimes some students end up presenting on Wednesday. But that's it. So all you have left is the project, A and B, and the final exam during the finals week. You will no homework assignment this week, obviously, but you do have a bonus lab if you choose to work on it. Got it? Make sense? That's it. All right, so today I'm just gonna go over what's left on Brightspace, kind of some miscellaneous topics, as I said. So we get a little bit 372. For completion, scripting examples. We went back to bash scripting, you remember. I did all the bash scripting examples, but go ahead and, a lot of them that I didn't do are pretty straightforward ones, but we did do some important ones the last time we met. We covered the S&MP lab, the Wireshark reading. This is probably the last Wireshark. We also cover set UID. So make sure to understand that topic. Just look at the recording again if you don't remember. That's an important topic that will be on the exam, right? So I can tell you right now, it's an exam type question. Then we covered grep and awk, so this topic has been covered. And this Wireshark, oh, this is also, I assigned that Wireshark. So that was probably your last one. All right, and then as you can see, just a few last topics that we have available. Case Aurora, I'll probably kind of start with file system analysis today. Just go over this briefly. All right, so file system analysis. So this would be the lab that is bonus lab. And you can see you have a Word document and a few PowerPoint slides. We'll talk a little bit about, as you can see, ethics there, just to kind of emphasize something, like I have to emphasize this, right, about ethics and system administration. So we'll talk a little bit about that. And you guys did the case, which is called, what is the name of the case? I think it's the first one. The cuckoo's egg, right? So you guys did the cuckoo's egg, and you did that lab assignment, I believe, right? So just have to stress there with the cuckoo's egg. Where did we do? Was this the homework? Yeah, cuckoo's egg homework. So I just need to stress here, right? So what do you guys remember the whole idea of the cuckoo's egg? It was somebody was hacking into some computer systems, and then the system administrator stall figured out what they were doing, right? So they were stealing the encrypted passwords and then running a password cracker, right? Because the users were using very easy passwords like egg and 12345 and so on. So it was easy to break it. So it's this case is also an ethics case. And so even though Stahl was doing this for security reasons, right? System administrators obviously have a lot of power, right? If you have, a root account or a system administrator account over many users, so you would be able to correct someone's password, like a legitimate person, right? Not somebody that's hacking, etc. Do you guys understand? So that's essentially the idea, okay? That you have all this power. So I'm supposed to say that with your system administration, that's kind of the whole point, right? But yeah, all right. Let's click on this one. All right, so this is what I'm going to talk about today, just briefly. Not all of it exactly, but so I'm sharing the script. Sharing. Okay, so we're going to talk about the file system, which is kind of everything learning about these dimensional, the layout of the files, the different folders that are there, mounting and unmounting. And then a little bit of ethics, as I said, I usually don't do the managerial slides, but this one we kind of have to address a little bit, just briefly. Okay. All right. So as you can see, you guys can see that. So, we have essentially this last bonus lab, this last chapter is just to kind of bring everything together. And the key concept of Linux, right, which is everything is a file, and then you have this hierarchical tree of folders where everything is organized and stored. So you can see here, you have the root folder, and then from there you have home, and you have var, and you have etc and user and so on. And these are all the different branches of the file system. Okay. So you can see the folders here. These are some of the common folders, and I'll just briefly talk about them. So you can see their bin is essential user command binary. So we've talked about this already. A lot of these folders like bin are in the environment variable so that whenever you do a command, you actually can find the script that corresponds to that command. But it's essential user command binaries. Boot is usually static files of the bootloader. The dev folder is for device files, for devices. etc we've used a lot this semester, if you remember, right? That's usually host-specific system configuration files. So these are required directories, that we need. The home folder is another big one that we've used a lot this semester, is where user home directories are located. So when you use user and groups and things like that, you use this folder. Lib would be a folder for essential shared libraries and kernel modules. Media is for mount point for removable media. Okay. Mount is if you want to mount a device. So mount point for a temporary mounted file system. So that actually the bonus lab is a lot about this, understanding the mount and unmount command, where you're going to load up, another drive, etc., into the file system. So that's essentially what that's about. Opt, these are add-on application software packages. SBIN is system binaries, another place where you can find binaries specifically for the system. Some of these we don't have on the CVM, like SRV. So these are generic for Unix. Different distros of Linux will have different folders and structures like that. Temp, obviously, that one's a big one that we've seen. That's just your temporary files, right? Remember, temp, when you turn off the machine, the files there are deleted. User, this is a multi-user utilities and applications. And it can have other things like bin in there, include, etc. var is for variable files. So this one is, files that can become really big, right? So files, for instance, log files can become really big. Email files can become really big. Websites, HTML, etc., can become really big. Root home directories for the root user. Proc is a virtual file system documenting kernel and process status as text files. So proc is very interesting because there's something called the Linux kernel module. So you can compile code, C code, that if you do it correctly following a certain procedure, you can actually add it to the kernel so that it runs in the background. This is, for instance, let's say that you built a firewall, right? You build a firewall, your own specialty firewall in C, C++. You want it to run really fast, not at the speed of Python when you run it on Bash, but actually really fast. So what you do is you write the C code in a format compatible with the Linux kernel module, and then you can load up the Linux kernel, the Linux kernel module into the actual kernel so that it runs really fast. So proc would be the place where things in the Linux kernel module can access data in the file system. So it's a special location that is meant to be external, but it's fast for kernel access, right? So going back to this example of the firewall, a firewall will have rules, right? So you'll have rules, as we saw in the UFW firewall lab, block this IP, blocked by this port. It's especially. So you may not want to have those rules hard-coded into the firewall that you run into the Linux kernel module. Instead, you want to have them somewhat external, right? But still associated with the Linux kernel module. So proc is exactly for that. So it seems a strange thing when you define it until you have a need for it, and then you're happy to have it. Because the thing with the rules on a firewall is that you want to maybe change them more often than you want to disconnect the Linux kernel module and reconnect it again. So proc is exactly for that. Okay. All right, so those are just some of the basic things with the file system. It's a basic distinction between shareable and unshareable, as well as static and variable data. So we've talked about that. As we know, you kind of summarized today, files are central to Unix. We have commands, we know about access control, and we've talked about all the other things like processes and process communication. I'm not going to repeat this, but you guys know we've talked about ownership as the key central thing, users, groups, etc., and permissions in access control. So these are the commands that we know about. You guys know read, write, and execute, which is pretty important, and how to use commands like chmod. Okay. So we've talked about the numeric, so I remind you of this as it could be on the exam again. Remember, the final exam is comprehensive, right? So anything that we've covered from beginning of the semester to the end. But yeah, so reading through these, we talked about the types of files that you have available, directories. Remember that directories are in fact files, right? They're just files containing information of what other files they are the parent of. Okay, there's links. We talked about symbolic links as well. Okay. We can, devices. This example, the bonus lab talks a little bit about devices, as you have to copy the device of one machine into another machine if you do decide to do it. So we'll talk about it in a second and the commands for it. But essentially, this shows you how, naming conventions that are used. when you're loading devices into the file system. Imagine you have tapes or some other device. So we've talked about this already, the Unix file system layout. So root directory, don't forget, it's just that / bin executables, dev is devices, etc is system configuration files, home, where the account home folders are located. Right, and we talked about all of these already as well. Now, mount the file system to the point of a tree. This is relevant to the bonus lab. Essentially, you can see what happens here. Let's say that you're working in forensics. You have a computer that was, part of a crime. So you take an image of that computer, and let's say that's this one over here, right? So you copy this on the desktop of another bigger computer that can hold something as big, and then essentially you can mount the entire file system of one Linux machine into another. Do you guys understand that? So so if I go back to the tree that I had at the beginning of this tree, imagine that I have another tree, a second tree, right? But this tree is for a machine that's 20 gigs. The other one is for a machine that's 3 gigs, and I have about 10 gigs available in space. So this smaller one will fit in memory. So then Linux, essentially, you can copy the entire file system of another machine as an image, and then you can go anywhere in the file structure of your Linux machine. Let's say you go to, let's go here to home and then Ben. And so at that point in Ben, you can connect the whole other tree here, and that's called mounting. So you're going to mount when you add it or unmount. All right. And so here you would say, mount this other tree and then Ben, right? And that's it. And that's it. And at that point, that whole file system of another machine becomes just part of this one seamlessly, and you can access it. Does it
like merge together?
Yeah. So if you think about it in Windows, right, what do we have? C drive, D drive, right? And things like that. But Linux is different because you can mount to a specific point in the C, let's say on the C drive, the whole D drive. And it becomes seamless as just one single file system. Do you understand? Yeah. So that's the key thing. So once you're in Ben, there was nothing there. But once you've mounted the whole file system, then now you go into Ben and you do ls-l, and now you see that whole other hierarchical data structure, and you can start navigating and using it. So that's what the bonus lab is about, and you'll see the commands for it. Does that make sense? Okay. So that's the neat thing about Linux is that it abstracts the drives like the hard drives and things like that, and it just can have one single file system, different things mounted. All right, so that's one of the key concepts with these slides today. Yeah, so we were talking about here. Yeah, here. So then essentially you have these two commands that I'm kind of introducing today, the mount and umount or unmount. So essentially this would be your drive, right? And then you mount this one into this one. And then if you want to remove it, you unmount users. One interesting thing that happens is that, let's say that you have some files in user, like you have 3 text files in there. And then you're in users, you do ls-l, you can see the 3 files listed. But once you mount this drive into users and you do ls, all you will see is what's in this drive, and the 3 files are not visible anymore. Essentially, you can hide them by doing that. But when you mount it, the 3 files will still be there. Right? So they remain in memory. It's just that it's covered by something else. So that's the idea. But here is the example. As I said, so you can mount a whole drive home into this into root essentially, and you can do that with several drives. You can create one single file system. So this is used for forensics and things like that. So the bonus lab talks a little bit about these two open source and free forensic tools called the Sleuth Kit. I'm not obviously I don't go into this for the semester. Essentially, you would be able to once you mounted one drive into another drive, you could analyze that drive and just look for like deleted files and things like that, and it just gives you a report. Yeah, I don't know. So we'll come back to this when we look at the Word document of file system analysis for the bonus lab. As I said, the last part, which is the one, you should be reading all the slides, remember, right? You could have questions about these on the exam. Remember the class has this technical side, but also this managerial side of sysadmin, right? So make sure you read through all those in the slides. Um, and then the last one that I will cover a little bit in the class today is ethics, given that, the idea is that you guys, if you work as a sysadmin, you do have a lot of power over the systems or an organization. You can look at things that are private, things like that. So these are just some thoughts that are provided. So issues, what policies related to ethics should a site have? Uh, what are the additional ethical responsibilities of system administrators and others with privileged technical access, right? So ethics, the principles of conduct that govern a group of people are different from morals. Morals are a proclamation of what is right and good. So remember, the one essential thing that might happen if you're working as a sysadmin is that you'll be governed by some laws, Sarbanes-Oxley for like accounting, Family Educational Right to Privacy Act, which is actually a law that relates to you guys, FERPA, and it's like protect your records, your academic record, and all that. And then, of course, there's HIPAA, which is health information as well. Right, so all of these, obviously, they're very powerful laws that affect how you conduct your work. Uh, so the occupation of system administration has been directly affected by these laws, even though a lot of these things just have to do with information. Information will usually be stored in information systems. So the system administrator's code of ethics, right? So this kind of have to conclude the semester with this. So essentially, your code of ethics, right? So professionally, you don't have to do scripting, Linux works really well, how to do cron jobs and create accounts, lock accounts, whole manner of things. So your code of ethics, you have to have professionalism, personal integrity, so like privacy, laws and policies, of course, are pretty important. Communication, um, you know, maintain system integrity, education, responsibility to computing community, social responsibility, and ethical responsibility. This is the code of ethics. So we can go into it just briefly, as I said, to kind of make sure you guys have heard this. So professionalism, I will maintain professional conduct in the workplace. Will not allow personal feelings or beliefs to cause me to treat people unfairly or unprofessionally. For integrity, I will be honest in my professional dealings. Okay. Forthcoming about my competence and the impact of my mistakes. Right? So I will seek assistance from others when required. I will avoid conflicts of interest and biases whenever possible. When my advice is sought, if I have a conflict of interest or bias, I will declare it appropriate and recuse myself if necessary. Privacy, I will access private information on computer systems only when it is necessary in the course of my technical duties. I will maintain and protect the confidentiality of any information to which I may have access, regardless of the method by which I came into knowledge of it. Yeah. Laws and policies. I will educate myself and others on relevant laws, regulations, and policies regarding the performance of my duties. Communication. I will communicate with management, users, and colleagues about computer matters of mutual interest. I will strive to listen to and understand the needs of all parties. System integrity. I will strive to ensure the necessary integrity, reliability, and availability of the systems for which I am responsible. I will design and maintain each system in a manner to support the purpose of the system to the organization. Education. I will continue to update and enhance my technical knowledge and other related skills. I will share my knowledge and experience with others. Responsibility to computing community. I will cooperate with the larger computing community to maintain the integrity of network and computer resources. Social responsibility. As an informed professional, I will encourage the writing and adoption of relevant policies and laws consistent with these ethical principles. Ethical responsibility. I will strive to build and maintain safe and healthy, productive workplace. I will do my best to make decisions consistent with the safety, privacy, and well-being of my community and the public, and to disclose promptly factors that might pose unexamined risks or dangers. I will accept and offer honest criticism, technical work as appropriate, and will credit properly the contributions of others. I will lead by example, maintain a high ethical standard and degree of professionalism in the performance of my duties. I will support colleagues and coworkers in following this code. Okay. Customer usage guidelines. Every organization needs a set of guidelines for acceptable use of an organization's computers. Okay. I think, yeah, so I think that was all of them, wasn't it? So ethical responsibility is the last one. So anyway, so yeah, so the system administrator's code of ethics, as I said, kind of like to wrap up, with these ideas. Any questions on this? Any thoughts on ethics of system administrators? Right. So with great power comes great responsibility. Right. So that's kind of the theme with it. All right, you can read the rest of it. As far as more recommendations, has some points to consider. Yeah, copyright. I mean, various things, law, and so on. All right. Yeah, go ahead.
Is that information also going to be on the exam?
Maybe.
Okay.
Maybe. It's everything that's in the slides could be on the exam. So, I mean, it's technically content, right? I mean, it's, as I've said many times during the semester, right? So the course it's system administration with Linux, but we focus mostly on the technical, but there is a whole managerial component, right? Because you deal with people, so customer service and things like that. So you should be reading all of them. That's on the slides. All the slides have that information, and it's fair game in the exam. But this one in particular, I wanted to stress, given that it's important, right? Okay, it's actually so important that it's like in the syllabus element I must address. All right. Anyway, but yeah, it's just a code of ethics essentially about sysadmin. Any other questions? All right, so we've covered that, right? So you guys looked at it. So now, so that's the slides. Make sure you read through all of them. We can go now, go to the Word document. Remember, that's related to a bonus lab. So you're not required to submit this. I do this to help out students that have missed an assignment, right? And instead, at this point, just work on your term projects. But let me just click stop here. When I use the slide, sometimes the system breaks a little. All right. So let's take a look at this document just briefly. I'll describe what the bonus lab is about, some of the issues to help you out. But it's essentially similar to the discussion we had on mount and unmount. So essentially, you have two computers. Okay. So you'll be using a lot of the commands that we have covered during the semester. But you will need to, to do this one, you will need to have, one is the CVM, right? One is the CVM. Make sure you know how much space you have available. And that's, these commands here, df and df-h. So let's say as an example, your CVM is 20 gigs, right? And you measure the space that you have available. What I mean by that is if you loaded a file on that, how big can that file be, right? So let's say that you determine that your machine is 20 gigs, but you have 8 gigs of memory available. Okay, great. Then you're going to, since you're going to be mounting an entire file system from another computer, that other computer has to be smaller. So you have to find a Linux VM, a Linux machine that, that is, I said 8 gigs, so that is 6 gigabytes. Do you see that? That's the key thing. If you try to load something bigger, it's gonna break. Okay. So you have to make sure that it's going to fit with a little bit of room in there. Okay. So let's say you have a machine that is 20 gigabytes, and then the file system of another machine is 6 gigabytes. The machine that has 20 gigabytes has 8 gigabytes of available memory. So then perfect. You would be able, you have you start up the two VMs in your virtual environment, and you then follow this tutorial, and you'll be able, using the commands, to make a copy, an image of the smaller machine and move it through a tunnel, right, through Netcat, right, into the desktop of the bigger computer as a file. Does that make sense? So once you run that and you finish, you'll have a file in your desktop, and that file is going to be about 6 gigabytes in size, and it's the whole file system of the other machine. So think of it as the 6 gigabyte machine is maybe, something that was compromised, and then, for investigation, people want to load it and analyze it with forensic tools, right? So you're thinking about it that way. So you're going to move it into the bigger machine. And once you have it on the desktop of the bigger machine, you're going to go to the terminal and you're going to mount it into the file system of the bigger machine. That's essentially the exercise. Do you guys understand? So that's, if you want to do this bonus lab, you have to achieve that goal. All right. So that's the idea. So we've talked about this already in the lecture today. So you'll measure the size. The df command allows you to see contents of a folder and space available. The mount and unmount commands allow you to mount an image. Linux has also fdisk command to display, which displays any partitions of a given image. So this is the idea of forensics. Okay. So you remember Netcat because we did this already. We did an example of a chat that we created between two VMs. So you're going to be doing something similar to that. You're going to create a tunnel between the two VMs, exactly kind of how we did that previously. So use Netcat traditional, open up a port, and anything that comes in through that port is redirected to victim.sda. Do you see that? So what you have to do is you open this port, and then on the other machine, you send like a copy of the entire file system to the forensic machine. So here is the, on the receiving machine, you run this command. You figure out the IP. So that's receiving host, by the way. So that word receiving host would be the IP of the machine that's receiving. So then to send the disk image to the receiving host network on port 1234, you will run this command, this DD command. So that DD command, and exactly like this, you take the image, you pipe it, as you can see, and you pipe it in with netcat to the receiving host on port 1234. That's it. Does that make sense? So the commands are not difficult. I mean, it's a big, obviously, if you're moving 6 gigs, right, you have to hope that it doesn't break. But yeah, that the key though is you have to make sure that that image will fit in the memory of the other machine. CVM will probably work as the receiving host, but then you have to have a smaller Linux machine that is up to you to find. Okay? Any questions on this idea? That's the bonus lab if you choose to do it. And you can read through the instructions here, but it's essentially what we've talked about. Here is the kind of little map of it. So here you have the disk that you're trying to copy. You use netcat, you send it through netcat through the network, or in this case, it's like your hub on VirtualBox, and it goes to port 1234, and that's the server, and then this is the image file essentially here. So this, what this example talks about is that maybe this is highly secure that needs to be done. So if you just use netcat, it would be in clear text, so it would not be encrypted. So starting from bullet 28, you can use an encrypted scheme, which is essentially the same process, but you add, if you notice, SSH. So you're going to create an SSH tunnel that allows you to send the data encrypted. And that's the command for it. That's it. So you just repeat it a second time. Once that's done, you will have an image in your desktop. Okay, there, like the machine that you want to do the forensic analysis on. So you're gonna create a folder. Maybe you go, in this example, it says to go to the root of the file system and use mkdir to create victim. So you'll create a directory called victim, and then you can go ahead and mount your image to victim, essentially. So you can see that there. And that should be it, basically. Once it's mounted, you can install these two programs, the Sleuth Kit, Autopsy, and just do some analysis of it, like whatever it gives you, like a list of files or list of deleted files. It'll give you a basic report of it. There's no scripts for this one, but that's the bonus lab. Are there any questions? It's not difficult as long as you have the two right VMs and there's enough space for it. Any question?
Go back to the bottom.
Yeah, sure. What's your question?
Uh,
There are no scripts for it. Yeah, a script that outputs list of files and permission in a readable manner. Yeah, you can. Don't do it. Skip it. Got it? Yeah. But anyway, yeah, go ahead, please. I believe so. Check the amount of space on seed and find a small one. Don't overcomplicate things. But I leave it to you guys, right? That's like the difficult part of this, and that's why it's bonus points. If you've done all the labs, I mean, it's still bonus points, right? So you can and earn some extra points. Got it? All right. Yeah, so that's this assignment. So file system analysis is, like one of the last topics that I cover in the semester. All right, we're going to talk about the next thing, which is the case Aurora. And I have a few scripts, so we'll probably need our virtual machine for this one. So I'm going to go ahead and start the virtual machine and look into wrapping up VirtualBox. So we only need one VM for this. That's starting. Let's give it a minute. So the DD command is a command in Linux for copying individual disk partitions. Okay. This creates a bit-for-bit identical copy of each file system, including all the meta information. Okay, so that's what that command is for. So it's perfect for the task of that lab, right? So you want to essentially just copy bit for bit that whole image, an identical copy. And so that's what the command is for. Starting up. Right, so that's that one. All right, the next one, as I said, is the case Aurora. Well, I guess we can start reading through it. And it's a nice case actually. It involves scripting and Linux, but it's also a cybersecurity one. So while that's loading, I should have it here. These are just files that you need. This requires like databases and things like that. So little databases. So let's open the Word doc. Should be a fun one. And then I have a few last scripting things. It's just taking a while. All right. Oh, there it is. All right. So here it is. Case. Given the following case, propose steps you could take as a system administrator to address the given scenario. And then there are some scripts before that might be helpful to implement some of this. All right, so let's take a look. So it says Operation Aurora and how the obvious was missed. So on January 14th, 2010, the United States learned of a coordinated, sophisticated, and prolonged computer attack that targeted Google, Adobe, and over 30 Fortune 100 companies. Dubbed Operation Aurora after a folder found in an infected machine. The attack used a novel exploit unseen in the wild. Although Microsoft knew of the vulnerability exploited in the attack, they falsely assumed that nobody else knew of the vulnerability, and therefore no mechanisms existed to detect such an attack. Does that make sense? So that's key. So now the attack. To exploit their victims, the attackers initiated the attack by sending the victims an email with a link to a German website with malicious JavaScript. When users clicked on the link, they would download a piece of malware that connected back to a command and control server located in Germany. From there, the attackers used their newly gained access to hunt for proprietary information stored on the exploited victim's system. All right. As obvious as this attack appears, it went undetected for several months and succeeded in penetrating the source code repositories of several Fortune 100 companies. Okay. So it's an industrial espionage type of thing. So what do you think? How could you, let's say you're a sysadmin and you've got something like this going on. It's on Linux, obviously. Let's keep it to the course, right? So it's on Linux. You have Linux and you have your skills and scripting and all the Linux commands and so on. What do you do? What is the essential problem, right? So malware is downloaded to the machine, and then that malware communicates with something called a command and control server located in Germany. You guys see that? And then from there, back and forth, and data is stolen. So obviously data is sent back. Well, what do you guys think? What could you do? So obviously the question, the problem here, and I could do something like this on the exam. I could give you a little problem like this and ask you to write a little script, right? So keep that in mind. So you might see something like that on the exam. Not as involved as this one probably, but just, a little script, let's say in Python. What do you do? Given everything that you know how to do, what are the problems, right? First of all, it went undetected. So it's almost a question of you have to anticipate something like this. You have to have the imagination to anticipate something like this, which is not easy, right? In hindsight, everything's easy. And before, you're like clueless, even with something's obvious, right? So, but anyway, so my point is there's essentially first the issue of detecting it. And then there's the issue of addressing it, right? So what do you guys think? What would you do in terms of Linux and scripting to both detect and address? So that's the case that I posed to you guys. What do you think? What would you do? Which problem is harder, detecting it or stopping it? Detecting it is more difficult. Okay. Okay. So how could you detect it? Processes in the background. Sure, sure, sure. Okay. So it's malware, right? So this is what you're thinking. Um, Process IDs. Yeah. Okay. Agreed. I mean, yeah, that's one solution. Anything else? Any other ideas? Okay. Well, let's say once you've detected it, how do you stop it then? What do you do? Yeah.
Could you implement like firewall logging?
Ah, okay. That's a good one. That's a good, okay. Keep going. Why?
Why? Because if you want the port and the server and it out, they will communicate with these people.
So what's particular about that IP address?
Yeah.
Yeah, so you're saying you have like a list of known friends, which are and their corresponding IPs, and a list of things that you don't know about, right? Yeah, so that's a good one. Yeah, exactly. All three of you are right, and that's a good thought. So in this example, the the key, you're right, you're on track. The key idea of this problem is that you can geolocate the IPs. So that's essentially the lesson here. So for instance, that's why the problem says Germany so much, right? So it says Germany like three times. And what it's trying to tell you is it's hinting at the fact that some of those IPs that you would be communicating with would be geolocated to Germany. So if you're doing a type of a security like this, then it's not a bad idea to geolocate all traffic. So you can have like a map of the world, right? And then somehow put in little lights on all the geolocations that you've identified. So as you said, you don't even need to have a list, essentially. You can just look at the map and say, okay, well, this is all traffic here in North America, China, you're doing a lot of traffic with China or something like that. But then you see something, this traffic in Germany that wasn't there, and then all of a sudden you're seeing it, right? And so you start to wonder, who do we communicate with in Germany? What is this traffic? And so that's essentially the problem. Do you guys see that? So that's the idea with geolocate. Okay. So that's what this problem is about. So we are going to then take a look at it and try to resolve it. And I'll give you the script for it. Um, and you'll see, so you'll be able, so how do you, obviously I'm not saying that you should download malware, right? Anything like that. You can easily test this. I always tell students to go. So remember that when you go to certain websites, uh, those IPs get cached. So they're going to get cached on servers, maybe in New York or in Los Angeles as they come into the United States. So you may not actually go out, right? And so that's when you geolocate them, they're not going to show as being from overseas. So what you should do is go to some university, um, some like in Japan. So usually the thing that has always worked for us, if you visit some university in Japan somewhere, by opening a browser, then when you're collecting that data, it's going to geolocate that IP to Japan. Do you see what I'm saying? And so that's what this script is going to be about, is to show you how to do geolocation. So you'll have the script in the background, collect some data, and then you know, and then basically print out. It's not very sophisticated. It just prints out the the countries basically. So we're gonna do that, and then do some other scripts to wrap up the the. So let's go to oops, to the terminal. This essentially has some functions, but it does have a little database, which is the one that I provided on Brightspace because you do need some information, and some of this is sold nowadays. Okay, so let's do ls-l. We're going to navigate to the desktop, clear ls-l, cd es 372 running 2025 later. No. All right, so let's do NKDIR. Let's call this one GeoLocate. Oops, that's not where. GeoLocate. So we can go into that folder there. All right, so let's think of the logic here. So we're gonna need a script. So nano geolocate dot py. Okay, and we're gonna need some libraries. One library that so we're gonna need import dpkt, import socket, import igeo, and that should be enough. Okay. So then we're gonna need to define function name, and this main, um, we can define it over here. So this is a call to it. So this is going to be define main colon 1, 2, 3, 4. So we're going to first open a file. This is going to be a pcap file. Open, and this is the file. So you need to open Wireshark, right? This is some websites, some universities in Japan, something like that. Select that data, save it as a pcap file, and then load it on here. Okay? So that then you can do the analysis and you can geolocate some IPs, and that gives you an idea. So here I'm just going to call it its name, geo s dot cap. Okay. 1, 2, 3, 4. Okay, and then you're going to read the pcap files. So pcap equal dkt dot pcap dot reader, and we give it file. Okay, 1, 2, 3, 4. All right, and then we need a function that is going to process the file. So we print pcap, and we provide to it the pcap file. Does that make sense? So that's essentially the script. So now we just need to define two functions. First one is print pcap. All right, so let's do define print pcap colon. So this takes in the pcap file with your data. 1, 2, 3, 4. So we're gonna iterate through this. We can do 4 TS comma BOF in pcap 4, 2, 3, 4. 1, 2, 3, 4. And now we're going to use a try in case there's any errors or anything like that. So we do try except. So if there's an exception, just ignore it. So 1, 2, 3, 4. Say pass. So here the try is where we define everything. 1, 2, 3, 4. So we have to extract the headers. In this case, what we care about is the IP address. So we're going to do ETH EPKT dot Ethernet Ethernet dot Ethernet, and we provide to it BOF. So that should give us an Ethernet header. Now we need to extract the IP information. So IP equal ETH dot data. And now we just extract the IP. So we're going to say source and destination. Okay, so source and destination. So for that, we're going to use socket, which is one of the libraries. So you can do socket dot init and we just provide IP dot source. And then for this one, we do socket dot init and FOA, and we do IP dot DST. You guys see that? So that's essentially pretty straightforward. We collect some PCAP data, we get it in a specific format, and we iterate through it through the PCAP file and grab all the packets in there, grab the Ethernet header, extract the IP data from there, get the source IP and destination IP. That's it. And then all we need is provide that IP to a function that will look to match the geolocation. Okay, so let's do here a simple example. Print. And I'm going to create a function here, the last part called ref geo, which retrieves geo string, retrieve geo string, and we're just going to provide the IP. So that's our C sharps. Okay, so that should be it. So now we can define a function here. Say define. Oops. So define retrieve geo string. And this takes an IP. 1, 2, 3, 4. Okay. So now what we have to do is instantiate the PyGeo database. That's the database that I provide on Brightspace. So in the past, you can get it from the internet, but just became easier just to have it. So for that, we would do GI equal PyGeo IP dot geo IP. I see that, and then we just need to have database, probably in the same folder in the data. I think it's called GeoDAS. That should be here. Should be this one of these two. So one, two. Here's a PDF file actually from data, so you can download that too. Yeah, this one, Geo1, Geo2. We'll need to obviously open this in the it's called geo1.dat. So geo1 dot dat. Okay. So that instantiates it. So now in the function retrieve geo, we can do another try, except just print 1, 2, 3, 4 times. All right. And then here, 1, 2, 3, 4. So this is essentially where we look up the IP in the database and provide um, the city or country. So we can say record. So GI dot record by name, record by name, and we provide the IP address. Okay. So here we just want to grab the country. Let's say country rec records. And this is going to be something like country code 3. Try that one. And then let's just print. And that should essentially, that should be it. You see that? So that's essentially the script. Let me look up something. Just confirming this for on my GitHub. Should be there. So I have, instead of downloading it from Brightspace, you can probably just download it from, let's go there, open a browser. Okay. Um, right, so it opened. Go ahead and go to the GitHub. Go to repos. Okay, and we're gonna scroll down to the repo for the course. There it is. Finish the Python. It should be this one, GeoLocate. Yeah, let's click on GeoLocate there. Right, and here is the PCAP file, geo.12, GeoLocate, and a PCAP file someday. So, to, as I download these individually. So it would be, let's download Geo1. Not sure if it the downloads. Yeah. Are you guys having the same issue downloading it? Very slow. All right. Let's download. We also need the PCAP file. Make our lives easier. All right, that's the PCAP file. So download that one too. Um, let's download. Oh, didn't mean to do that. But you can see that's the PCAP file. Then also download geodat2. And we're going to download the script just in case. Okay, so we download that one, geodat2, there it is. Saved file. Finally, geolocate py. Just did that, but okay, well, let's just look at it. So RB, yeah, every time just does that. All right, I'm going to copy this just in case. Okay. Whoops. Yeah. Copy. All right. So now we should have everything. Okay. So let's go back to the terminal. Let's check down. Let's see. Geo.1, Geo.2. Where's the pcap file? Do you guys see the pcap file? Huh. So let's try to download that one. Cap. Oh, okay. So save file. I must have clicked on something. Save file. All right. So now there it is. Right. Some data pcap, and we have the dot geo1 and 2 dot dat. All right. So now let's proceed. So they're in the downloads folder, and then we have this script here. So let's actually paste in the code from the repo just in case. Got a few improvements. All right, so Control X, Y, Enter. There. So now how do I move this file to the downloads, or do I move those files from the downloads here? Right? So what would it be? So this is PWD. Um, so it's gonna be in home, documents, downloads. So downloads is in home, and it's geo1 dot geo2 dot and then some data dot pcap, right? So SAM type question, right? Copy those from one folder to the other. So it should be CP, right? Home, downloads, um, geo geo1 dot dat, correct? To the current working directory, which should be this one. Uh, there. Station operator.
You have to build it directly, but not instantly.
Yeah, but This is correct, right? Geo1.dat, so I'm not making any mistakes. All right. So what is this? PWD. We can do that. Did I? I'm just gonna type this. Home. Oh, okay. That's what it is. I'm not doing, it's home seed. I knew there was something like that. Right? You guys see that? It's home seed, right? That's what I, there we go. So we just copied the one, so the other one should be pretty easy now. Two. And then what was the PCAP file? Do you guys remember the name? It was something like some data dot PCAP. Okay, so that looks good. All right, so I've got the files that I need, right? So we've copied. So now I can proceed to look at this script and I integrate it a little bit better. GeoLocate. All right. Still okay. So here in I have here in the geo retrieve, I have actually an IP address that I got directly. That's another way of doing it. Test it out. So let's try this one first. I'm going to comment out the first one. Just add three single quotes and then these single quotes here, like that. So I've commented out the code, and now I can test it out. So I'm going to read some data. Actually, test one seems to be the one. Some data. .pcap, read it, run it into the function. So let's try this out in Mr. Python. Module GeoIP. From GeoIP import Geo light. So let's do GeoIP. Let's so GeoIP. Oh, there's an error. Let me try it again. You guys are trying this to go through for you. Try pick three. Okay, control script. Yeah, GeoIP is a little bit. Let's try the other version then. See if this one works. All right. So, so this one has a main geo some data. Can you have, yeah, let's try it. Okay. Well, at least no library errors. Type. Okay, let's try it. Let's out. If that's just RB for the PCAP. All right. Okay. It worked. It worked. All right. It didn't find, so it's printing, but it's not finding a country. You guys see that? So let's now take a look. It could be that my peacock just didn't have correct data. That's why in this script, I gave it a specific like, P. So let's try that 14,139,61,12. GI country name by address. How do I copy this? Go over here. It's just going to be res equal vi dot country name by T dot 39.61.12. Right, so let's try this one. I'm going to print res also. Let's try it. No. Oh, the other database, Geo.2. So, I think I'm going to try the other PM. It's like frozen. Okay, yeah, the screen froze. But anyway, so I'll keep trying this. I think maybe the other PCAP file may have some entries. But yeah, that's kind of the sample I'm doing geolocated. If this hadn't worked, it should have printed out some country. I'm just not seeing anything there. All right, guys, so we're going to stop here for today. Um,
stuff.